Hey everyone, and welcome. Whether you're waiting for dinner, your groceries, or maybe a ride, you've probably found yourself staring at that little car or bike icon, just watching it make its way to you on a map. Well, today, we're gonna pull back the curtain on that everyday magic. Let's dive right in. I mean, it seems so simple, right? Doesn't it? Just a little dot moving across a map telling you exactly when your pizza's gonna show up. But how does that actually work? How does your phone know, second by second, exactly where that rider is? And how does it look so flawless? That's the mystery we're gonna solve today. All right, so the whole story, the entire journey of that little dot, it all starts in one place, the delivery rider's smartphone. That device is the ground zero for every single update you see on your screen. So at its absolute core, this whole system is built on one tiny piece of data, a GPS coordinate. The Riders app is basically asking the phone over and over, hey, where are we right now? And it's doing this every few seconds. But here's the thing, just relying on GPS alone, that's not always good enough to get a really accurate location. This is where things get really, really clever. See, your phone doesn't just use GPS, which can be kind of weak if you're indoors or in a city with tall buildings. Instead, it uses something called a fused location provider. Think of it like a brilliant detective who isn't just relying on one witness. It's using multiple clues, the GPS signal, nearby Wi-Fi networks, and cell tower signals to triangulate and pinpoint the rider's most precise location. It's pretty cool. Okay, so here's a question. If the app needs to be running to send all this location data, what happens if the rider switches over to their music app or just puts the phone in their pocket? Does the tracking just stop? Well, no, of course not. And the solution is something you've definitely seen before. The answer is something called a Foreground Service. It's basically a special process that tells the phone's operating system, hey, this is super important, don't shut me down, keep me running. It's the reason you see that little notification at the top of your screen that says something like tracking your delivery, that little banner. It's not just for looks. It's the key that makes sure this whole data journey can continue, completely uninterrupted. So now we've got this steady stream of super accurate location data coming from the rider's phone. But, that data needs to get from the rider to you. And the next stop on this journey is the company's central brain, the backend server. The server acts like an incredibly fast traffic controller. In the blink of an eye, it does three things. 1, it catches the new latitude and longitude from the rider. 2, it zips that info into a high-speed database, something like Redis. And 3, it immediately broadcasts those new coordinates out to the right customer, which is you. This all happens so fast you wouldn't even notice. So how does it do that broadcast so incredibly fast? Well, it uses a technology called a WebSocket. And honestly, the best way to think about this is like an open phone line. Instead of your app having to call the server every few seconds and ask anything new, any updates yet, the WebSocket just keeps that line open constantly. So the second the server gets a new notation, it can just whisper it right down that open line, straight to your app. It's way, way more efficient. Okay, we've followed the data from the rider's phone all the way to the server in the cloud. We're on the final leg of the journey now, getting that little dot to actually move across the map on your screen. Right, so your app, the one you're staring at, it's basically just a subscriber. It's got that open WebSocket line, and it's just listening, patiently waiting for the server to send it new coordinates. The moment a new little packet of data arrives, your app knows exactly what to do. Move the dot on the map. But wait a minute, here's another little puzzle. GPS data, even with all that fusing, isn't always perfect. Sometimes the coordinates can be a little off, which, if you just plotted them, would make the icon on your map look like it's erratically jumping all over the place. So how do they get that smooth, fluid animation of a car just driving down the road? The secret here is a really clever algorithm, usually something called a Kalman filter. You can think of it as a digital smoother. It looks at the last few locations, it considers the rider's speed and direction, and then it makes a really smart prediction about where the rider should be next. This is what smooths out all those jittery or inaccurate GPS points, making the icon look like it's actually driving, not just teleporting from one point to the next. Now, all of this sounds fantastic in a perfect world, right? But what about the real world? The one with spotty internet connections and the constant need to save your phone's battery? Well, engineers have to solve for that too. And they do it with a couple of key optimizations. First, there's offline caching. If a rider goes through a tunnel and loses internet, the app doesn't just give up, it starts saving all those location points right there on the phone. Then, once the connection is back, it sends the whole batch at once. And second, they use update throttling. Sending a GPS update every single second would absolutely destroy a phone's battery. So they throttle it, sending updates every 5 or 10 seconds instead. And this right here, this is the brilliant trade-off. Yeah, you could have perfectly to-the-millisecond real-time updates, but the writer's battery would be dead in no time. By throttling the updates, you get a huge boost in battery life in exchange for an experience that's just almost real-time. And for you, the user, the difference is basically unnoticeable. But for the writer, it's a total game changer. It's just a really smart compromise. Okay, so we've looked at all the individual pieces of this incredible puzzle. Now let's bring it all together for the grand finale and see the whole picture in action. You see, that simple little dot moving across your screen, it isn't magic at all. It's a perfectly timed symphony of technology. It's the seamless coordination between the writer's app, the backend server, and your own phone, all working together in perfect harmony to turn raw data into a real-time story. So the next time you're tracking an order, you're literally watching this formula play out. You've got the GPS data captured by a foreground service, sent through a WebSocket, processed by a database like Redis, and then drawn smoothly on your screen by the Maps SDK. That right there, that's the complete recipe for live location tracking. And really, it's not just about data points on a map. It's about transformation. You're watching a perfectly synced system take raw, invisible information, just a string of numbers, and turn it into a meaningful visual story that answers that one simple question we all have. Where's my order? So, I'll leave you with this final thought. Now that you know about the complex dance of technology happening behind that simple map, what else in your daily life works like this? What other bits of everyday magic are being powered by a hidden symphony of code?